All right, guys. Today on 9/20/2016, we had a practice problem at the beginning of class to go over area model. And I let you know that I would put the one that was on the back of that worksheet online as a video so that you could reference it on how we created area models. So let's go ahead and do this one together. So this one says Julie has a dice and a spinner with the numbers 5, 10, 15, 20. So here's the dice. We know that a dice has numbers 1 through 6. And here's our spinner. You can see 5, 10, 15, 20. They want us to create a tree diagram or an area model to represent all possible outcomes for this activity. Since I have another video on tree diagrams, I'm going to go ahead and just stick with the area model to show you how you can find all possible outcomes, or what we call sample space. So I'm going to create what looks like a rectangle. We talked about how area model is just like finding the area of a rectangle or square. You're taking the length times the width. Okay, it's very similar. So the very first thing I did was I rolled a dice. So I'm going to go ahead and split my rectangle up into 6 equal columns to represent each number on the dice. 1, 2, 3, 4, 5. Oh, I forgot a column, and 6. So I could get a 1, I could get a 2, I could get a 3, a 4, a 5, or a 6 on the dice. The next thing I did was I spun the spinner, and the spinner has 4 different outcomes that are equally distributed on the spinner. I have 5, 10, 15, or 20. So I'm going to create 4 rows that represents each one of those outcomes. And obviously I'm trying to keep them equal. So I have 5, 10, 15, and 20. Okay, so this is the dice. This is the spinner. So I'm going to go ahead and fill in my area model. So I could roll the dice and get a 1 and spin the spinner and land on 5. I could roll the dice and get a 2, land on the spinner and get a 5. I could roll the dice, get a 3, spinner, get a 5. I'm hoping you're catching on to the pattern. Roll the dice, get a 5, spin, get a 5. Roll the dice, get a 6, spin, get a 5. Then I would do the same thing. I could roll the dice and get a 1, and on the spinner I can get a 10. I'm going to go ahead and finish filling these in. Okay. Then I would move down here. Again, I could roll the dice and get a 1, spin the spinner, get a 15. And then last but not least, I could roll a dice, get a 1, spin the spinner, get a 20, roll the dice, get a 2, spin the spinner, get a 20, and so on. Okay. I have all of my possible outcomes on my area model. Each one of these boxes represents an outcome. And instead of counting them one by one, I can just think of area. This is 1, 2, 3, 4, 5, 6, a 6 by 4 rectangle. So 6 times 4 would give you 24 outcomes in all. Okay? Then I could go ahead and list all of these down here. I could list 1, 5, 2, 5, 3, 5 until I have all 24 listed out. Okay. And then this last one says, what is the probability that you will get the same number when rolling the dice and spinning the spinner? So I'm looking to see, when will I get the same number where my dice lands on that number and my spinner lands on the exact same number? Well, if I look up here, the only one that has that outcome of rolling the dice and getting a number and then spinning the spinner and getting the exact same number is this outcome right here, 5 and 5. There are no other outcomes where I get the same number that I roll on the dice and I get the same number on the spinner. So that would be one possible outcome out of the 24 outcomes in all.